Today we're looking for a range of x's such that this logarithm with a variable base is actually less than 0. That is, the functional value of a logarithm less than 0 for a particular set of x's that make this condition hold. Now let's do some preliminary stuff here to get a feel for the approach, at least that I took on this problem. Let's say we have log, and I'll use b here. Sometimes the letters get overloaded. And folks, I will drop the x here, but this certainly doesn't say b raised to the x power. This is a log function base b. Now, what we're going to do right here is take a look at what this graph would look like when b is between. And this is fairly uncommon in college. I think the college math courses don't talk about bases that much between 0 and 1, but it is legitimate. Now, so we're going to make the assumption that the base is a number strictly greater than 0 and strictly less than 1. Okay, and we're going to look at the graph of this. Now, let's draw a picture here. Now, there's one key point on the graph of any logarithm, and that's not shifted. That's the point of 1, 0. And that's because anything raised to the 0 power is 1. Okay, so the shape of this is kind of the opposite of the more familiar logarithm graph that you're familiar with. Looks something like this. Okay, and I'm going to keep extending this to make a point here, so you'll get a feel, kind of a sanity check that this is right. Y'all remember the shape of the standard logarithm where the base is bigger than 1 goes up and over like this, okay? So you can kind of get a feel for what's going on here. Now, I'm going to go ahead and make an assumption that b is equal to 1/3, because that would meet our conditions here. Let me write it right up here. B equals 1/3. I could pick any number, but I've already thought of a calculation here. 1/3 is certainly a number between 0 and 1. Okay, I'm going to write a point on the graph, and you're going to see what I'm getting at here. And of course, this is not going to be to scale. Okay, a point on this graph would be 81, -4. Now, y'all remember, a logarithm is an exponent. And so the point on this graph is there because 1/3 raised to the -4 because of the properties of the exponents, negative exponents in particular, is equal to 81, right? Now, I think it's been worth the time to show you this, because what we have to do to make sure that this statement is true is we have to force this condition of being trapped between 0 and 1 on this variable base. See, it's totally consistent with what I've shown you up here. Okay, so we're going to force our variable exponent to be between 0 and 1, because that's how the graph gets to be negative, right? Okay, so now from here, what do we have? This would be equivalent to what? 7/6 is less than x is less than 49/6. Okay. So y'all, this is the answer we're looking for. It's an interesting problem, I think. I think it's a cut above a problem that appears in the standard United States college algebra textbook, or even pre-calculus. All right, it's not a common sort of problem that I've seen. Let me know if you've seen a problem like this, but I don't think it's a standard, vanilla type problem that you see in college textbooks. Okay, now, so this is the answer to the problem. Now, let's also note that what is a number that would be in this 49/6 is a little bit bigger than 8. So 7 itself is in this set, right? 7 is between 7 over 6 and 49 over 6, right? So let's try that out right down here and just do a sanity check. So let's try x equals 7. We're anticipating a logarithm that'll be negative, right? So this gives us the log of, now if you put a 7 right here, you get 1, right? And 1 minus 1/6 is 5/6. So we do get a base that is between 0 and 1. The log of 5 over 6, the log base 5 over 6. And I'll go ahead and do the parenthetical here, just to, I like it better. It gets dropped so much, but, okay, now, so we're asking a question. Is this negative? Well, conceptually, we know that it's negative, but if you want to do our good friend, the change of base formula, this is equal to the log base 10 or natural log, those are the two that we know, of 7 over the log of 5 over 6. And we know just from the standard graph of the logarithm that log of 5 over 6 is negative, right? Remember, because it would be to the left of the point. If you guys remember the regular graph, just when we shift bases, we're talking about this logarithm function right here, right? Look something like this. So you see that's 1, 0, this point right here, right? And 5 over 6 is just a point about, let's say right here, this would be the location of 5 over 6, right? So you see down here, it would be, you're talking about negative a's. So this is definitely less than 0, okay? And you'll get something similar if you pick any number in this interval, which more or less proves what we set out to prove numerically at least, okay? So anyway, this is the final answer. All the x between these two values force this logarithm to be less than 0. Okay, that's all. Thanks for being.